Okay, welcome back, students. We're going to jump into chapter 7 now, okay, where we talk about non-right triangles. How do we use trigonometry to figure out sides and angles of non-right triangles, or what we call oblique triangles? Let's go ahead and jump into that. All right. So oblique triangles and the law of sines. Okay, law of sines, in any triangle, that's any triangle, okay, even non-right triangles. Okay, so maybe we'll circle the word any there. Triangle ABC with sides A, B, and C, the following holds. The sine of angle A over side A, and the A's are always opposite each other. Okay, the lowercase are the sides, the uppercase are the angles. So this A, okay, is an angle, and this A is a side. Okay, and they're always opposite each other. Angle A is opposite angle, or opposite side A. Okay, lowercase is side, uppercase is angle. Okay, is equal to sine B over side B, so B is here, is equal to sine C over side C. Okay, so A, B, C. Okay, A is opposite A, B is opposite B, and C is opposite C. Okay, the ratio of the sine of an angle to its opposite side are the same for all three sides. Note, an oblique triangle is a non-right triangle, oblique triangle. Okay, solving oblique triangles. Okay, so if we're given a side, an angle, and an angle, okay, or an angle, a side, an angle, basically if we're given two angles, for this case, we can use the law of sines. If we're given side angle, we can a side, and then an angle that's not in between the sides, okay? It's a non-adjacent side, a non-adjacent angle, is what we call that. Okay, that's the ambiguous case. Okay, we could get, for the ambiguous case, it could give us 0, 1, or 2 triangles. Okay, that's the ambiguous case. It means that we don't know how many triangles. For SAA, there's only one triangle that this can occur. Okay, one triangle. Okay, and for the first two cases, we're going to deal with these two cases with the law of sines. And then in section 7.3, we'll deal with the other two cases with something called the law of cosines. But that will be next lesson. Okay, so that's when we have a side, an angle, and a side, and the angle is in between the two sides, or we're just given three sides. We use something called the law of cosines. So we're going to start with the law of sines. Okay, side angle angle, okay, or side angle, okay, and then the ambiguous case can be 1, 0, 1, or 2 triangles, and so we say don't let ASS, okay, don't let angle side mesh you up, okay, don't be whatever that is that it reads, okay, don't let the ambiguous case make n blank out of you, okay. Okay, tip. When solving a triangle, draw a scale version of the triangle and check answers for reasonableness. Okay, solve the triangle ABC. If triangle A is 28.8, C is 102.6, and little c is 25.3. So we're going to draw a mock-up version of this. Okay, I don't really know what it looks like, but I'm just going to draw a generic triangle. Okay, and we'll call this angle A We'll call this angle B and this angle C. Okay, so we know that angle C, it really doesn't look like this because angle C is what? Angle C is an obtuse triangle, or it's an obtuse angle, which is going to make an obtuse triangle. So that's going to change the angle here. So let me do that a little bit. Let's change the way that this looks. So maybe B is over here and C is down there now. And so we get that obtuse angle 102.6. Okay. And the angle A is 28.8. What we want to do is we want to find out what are all the other sides and angles. We have two angles, A, C. How do we get B? How do we get that third angle? Well, we subtract it from 180, the other two angles. So, angle B is equal to 180 minus 28.8 degrees minus 102.6 degrees. Okay, and so angle B is going to be equal to what? We want to take 180 minus the 102.6 or 28.8, 28.8 minus 102.6 will give us 48.6, okay, as angle B. Okay, so angle B was 48.6 degrees. Okay, so now we have all three angles. That's cool. 48.6. Okay, so we have angle A, angle C, and angle B. Now we just need the sides. Well, we know that side C is 25.3. So what I'm looking for is I'm looking for angle or side B, and I'm looking for side A. That's really what I'm looking for there. Side B and side A. So we can use the relationships inside this triangle. Oops. Bring that back. See if I can just erase just a little bit of it. 102.6. Okay, so now what can we do here? Well, we know this is side C. Okay, and so we can say, well, sine of C over C is equal to the sine of A over A. And I can solve for little a. Let me show you how I do that. I multiply both sides by A. Okay, and then I multiply by the reciprocal of sine C over C. Okay, so this becomes A is equal to, okay, the A's cancel over here. This is sine A times the reciprocal of sine C over C, which is C over sine C. Okay, so A is going to be equal to that. I just multiplied by the reciprocal of on both sides of sine C over C. Okay, so A is going to be equal to sine A C over sine C. And so A is equal to the sine of 28.8 times C, which is 25.3, over the sine of 102.6. 102.6. Okay, and let's see what that comes out to be, approximately. Okay, so we have the sine of 28.8 times 25.3 divided by the sine. Make sure that I'm in degrees mode. Nope, I'm not. I need to make sure I'm in degrees mode. Enter. Okay, quit. Okay, all over sine of 20 or 102.6, right? 102.6. Okay, and that's about 12.5 inches is the units that we're using on this problem. So this is about 12.5 inches. So that was side A. Okay, so angle B. If they give us three pieces of the triangle, we're really looking for the other three pieces, right? Because there's only 6 parts of a triangle. There's the sides and the angles. 3 sides, 3 angles. So if they give us 3 pieces, we're looking for the other 3 pieces. Okay. And so sine 28.8, 25.3 over sine 102.6, 12.5 inches. So that's A. Now let's look for B. B, what's B going to be? Well, B is going to be the exact same setup as we had before, except that instead of A, it's just going to be B. So sine B over B. So if I basically cross multiply and divide, I get B is equal to C times sine B over sine C. I can just say this is B is equal to sine B times C over sine C. Okay. Okay, and then what is B? B is sine of 48.6 times 25.3 over the sine of 102.6. And so B is going to be approximately, going to do the calculator, I can actually just kind of grab that guy and just change it from 28.8 to 48.6. Save me a little bit of writing. 48.6. Oops. Okay, and that comes out to about 19.4 inches. Well, I round in there as tenth because that's what they gave me. They gave me C in terms of tenths. So this is 19.4 inches. Okay, so if we go back to our triangle here, we look at our triangle. Okay, B and A ended up being 12.5 inches, and B is 19.4 inches. And we want to ask ourselves, does this make sense? Okay, does it make sense that the smallest side is opposite the smallest angle? And yes, that does make sense. Does it make sense that the middle side is opposite the middle sized angle? The middle sized side is opposite the middle sized angle. Yeah, that makes sense. And what about the largest angle opposite the largest side? That 25.3 would be the largest side. Yes, that all makes sense. Okay, so we solved that triangle. Let's use the law of sines to solve a problem, okay, a real life application. The bearing of a lighthouse from a ship was found to be north 52 west. Okay, so bearing of a lighthouse was north, this is west, north 52 degrees west. Okay, so this is going to be from north, we're going 52 degrees west. Okay. North 52 degrees west. Okay, if a ship sailed 5.8 kilometers due, the bearing from a lighthouse from a ship, right? So this is the lighthouse here. I'll put the little lighthouse here. Maybe it's on an island, who knows? Okay, and it's got a little light that's shining out. Okay, so the bearing to the, and this is the ship. Okay, if the ship sailed 5.8 kilometers due south, so 5.8 kilometers due south, the new bearing was 23 from here to here. Oops. Okay. I'll go down a little bit more. Okay. Erase this. Okay, now the new bearing is 23 degrees. Okay, so the old bearing was 52 degrees from north. The new bearing is 23 degrees from north, okay, after it goes down 5.8 kilometers. So we have this triangle. Let me highlight the triangle that we're looking at. Okay, so the triangle is right here. Okay, there's our triangle. And we have an angle here of 23 degrees. Okay, we have a side of 5.8. I'd like to get this angle here. Now, how would I get that angle there? Well, I do know that we have a right angle right here, and that's 90 degrees. I do know that I have this other piece of angle there, and that 52 degrees plus that angle will make the other right angle here. Okay, so if I take 52 degrees and I subtract it from 90 and then add 90, or subtract 52 degrees from 180, because this whole thing is, this whole angle here is on a line, and this is the 52 degrees, the other piece of that. Okay, so if I go 180 minus 52 degrees, okay, I get 128 degrees. So that's this angle, that's that angle there. Okay, so it's not 90 degrees. See if I can erase this. Okay. So this whole angle here is 128. Okay, and we really want to know, well, what's the opposite of that? So we'll call this side C. We'll call this angle C. We'll call this angle A. We'll call this over here angle B. And so I really want angle B as well. Okay. Okay, so angle B is going to be equal to 180 minus, this thing is 128, right? 120. If I get rid of this stupid. Problem is that my eraser is not too accurate. Let me see if I can make it more accurate. Get rid of the 128. Nope. Hopefully I didn't just freeze everything. Okay. Not good. Okay, there we go. Come on, go away. Okay. So once again, we have this thing here, and this is, the whole thing is 128. Okay, not just this little piece. I'm just gonna draw the thing over again. Here's the low, that was good. There's the bearing from that guy. Let's draw this one. Okay, so this whole angle here is 128 degrees. And 23, so angle B is going to be 180 minus 128 minus 23 degrees. So angle B is going to be equal to, this is 52 minus 23 degrees, which is equal to 29 degrees. Okay, so this is 29 degrees there. So now I can use the law of sines, because I have trying to erase. Okay, now I have Okay, I have an angle. Let me do this in a different color. Maybe light blue. I have an angle opposite an angle. And let's make this green. Light green. Okay, and then we have an angle, okay, opposite a side. Okay, angle opposite side, angle opposite side. So we can say that the sine, okay, the sine of angle B over side B, which we're going to call 5.2, is equal to the angle C, sine C over side C. And C, side C is what we're really looking for. Okay, so this is going to be the sine this is going to be the sine of 29 over 5.2 is equal to the sine of 128 over C. Okay, so what I can do is I can multiply, or I could divide both sides by 1 over, no, that's not going to work. Maybe I'll cross multiply. Sine of 128, so let's cross multiply. So we get C is equal to, or sine of 29, C times C. Maybe I'll put the C in front. C times sine 29 is equal to 5.2 times the sine of 128. Divide by the sine of 29. And so C is going to be approximately what? So 5.2. Let's see if this one works. Okay, trigonometry. Okay, so we're going to do the 5.8 times, and this has reverse notation. We got to put the number in and then do it backwards. So this is going to be the sine of 128. So 128, and then I have to go trigonometry sine. So that's 5.8 times the sine of 128 divided by 29, and then sine equals. Okay, and that's about 9.4 kilometers. Okay. 9.4 kilometers is how far the boat is now from the lighthouse. Okay. Let's do one more here real quick. Okay. Okay, given the ambiguous case, SSA can lead to no triangle, two triangles, or one triangle. So we want to solve triangle ABC. Okay, if A is equal to 17.9, okay, C is 13.2, and C is 75 degrees and 30 minutes. So 30 minutes is 30 over 60, which is 0.5. So this is 75.5 degrees. I'll just do that real quick. Okay, so if we draw a triangle, okay, we know that the angle is 75.5 degrees. Okay, I'm going to call that angle C. Okay, and then side C is 13.2. The only problem is that we don't know where it's going to intersect. Okay, if we put angle A here and call this side A, okay, we know that A was 17.9. Okay, but we want to find out, well, what's and C is 13.2. What's angle A, right? We could use the law of sines to find angle A. 13.2. So we have the sine of A over little a is equal to the sine of C over little c. Okay. Except we don't necessarily know how long side B is, or what the angles here, we have very limited knowledge of what the angles, we just have these two sides. And the two sides could either not be long enough. Okay, I could have a side that's just not long enough and it doesn't create a triangle. That would give me no triangles. I have a side that is long enough, okay, and just creates one triangle. Or I could have a side that could actually create two triangles, depending upon how I swung it. Right? Depending upon what the angle is, if the angle was obtuse or acute for A, that could actually create two different triangles, just given the limited information that I only have two sides. If this is 13.2, right? And then the other side was 17.9. I don't really know what that third side looks like. I don't know what side C looks like or side B looks like. I don't know if it's long enough. Maybe side B isn't long enough to create two triangles. Maybe it's only long enough to create one triangle. Maybe it's not, maybe side B, which is this side here, is only long enough is not even long enough to create a triangle. Who knows? Okay, but the law of sines can tell us that. It can tell us which case we have, whether we have a no triangle case, a two triangle case, or a one triangle case, depending upon what the angle is that we get when we come out with angle A, right? Because we're trying to solve for angle A here. Okay, so let's do that. We have the sine of A, okay, all over little a, which is 17.9, is equal to the sine of C, which is 75.5, all over little c, which is 13.2. So now I'm going to multiply both sides by 17.9. And I'll end up with the sine of A is equal to 1.3. Okay, let's plug that in the calculator. I'll show you. Okay, if the calculator is working. Hopefully it does, just for this one calculation. If not, I'm going to have to reboot my computer before they do the next video. Okay, clear that. So we want 17.9. Okay, yeah, 17.9 times the sine of 75.5. So the sine of 75.5, sine of 75.5 times 17.9 divided by 13.2. Okay, it's about 1.3. Now, I'm going to click out of that so that I get more RAM here. I'm going to stop sharing for a second so I can just go back to my regular app. It doesn't seem to be wanting to work. Okay, let's reboot that again. Sorry for the technical difficulties on this video, but some days are like that, and we just roll with it. Okay, so your screen. Okay. So we have sine of 1.a of 1.3. Now, if I try to do the inverse sine of 1.3, I'm going to get an error. Okay, this is not good. Why is it not good? You know, think about that for a second. Why is the sine of A being 1.3 not good? What's the range of sine? What's the range of the sine? I can only go up to 1 and down to -1, right, for the sine value? So is there any angle that will ever produce a sine of 1.3? No. Okay, so what do we say? No triangle exists. Okay, and I'm gonna reboot my computer, and I will see you in the next video. Okay, we'll continue with 7.1, 7.2 in the next video.